Good morning, everybody. Thanks for joining me again today. On the agenda, drakon render again. I'll be continuing my work that I started yesterday, and that is going to be to implement new types of skewer blocks. And specifically, I'm going to focus on words today. So if we look at the documentation, or the drakon white paper, the words are here, and this is getting pretty interesting now. I'm also going to open my printed copy for a quick reference, because the paper is organized in such a way that you just need to flip between pages. But that is all right. Okay, got it. So let's keep this open here. That is much better. So the documentations, or the white paper, says that a skewer block, aside from the letters we've already implemented yesterday, can also be a word that ranges from 4 to 21. So it can either be a switch, an arrow loop, or any of these. So what I'm going to do today is just, I will add these to the skewer blocks. And for the time being, I don't think I will distinguish between words and letters in my representation, simply because I'm not really sure how it would make sense to lay them out, but I will leave a comment. That distinction will come naturally, I believe, as soon as we try to insert words and letters into valence points. But for now, I think we're just good to add these words here. What I'm not sure about is why the white paper does not include word number 3 in the list of skewer blocks, if it includes the word number 4 in the list of skewer blocks. So I'm going to assume that there is an error in the white paper, and the fork should also be included in the list of skewers. So let's get to work. Today's session should be interesting, specifically in the latter part of it, when I'll try to represent these skewer blocks that are words somehow. I don't have an idea what to do with them yet, but if you take a look, skewer blocks that are letters, we've already done yesterday. They're pretty straightforward to represent. Skewer blocks that are words will require some thinking. I have some ideas, but let's see if they are feasible. Having said that, I hope you have your coffee or tea ready. I have my lovely coffee. And yeah, let's get to work. That's icon number 3 for a switch. So I'll just leave a comment here that these are letters. And letters end here. So all of these are skewer blocks. Let's check the documentation. I keep saying documentation, it's a white paper. So we'll be adding all of them. Timer driven start timer. Okay. We will definitely have to make these a little bit longer if we want to accommodate everything. But you know what? Maybe not this time. Okay, it looks like we have everything. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh no, we're missing something. Fork, switch, arrow loop, switch loop, for loop, wait loop, timer driven action, shelf, fork, switch. Okay. Now show. Oh, this will be fun. Oops. Okay, I didn't expect any hiccups here, but this is where I believe it will start getting really interesting, because we'll need a different sort of basic visual representation for words. As those words can contain valence points in which we can perform insertions. So, for example, that fork, the content will be displayed here, but we will no longer be able to show, to represent it as a visual block, we'll need a fork block. So we have two directions to explore. One, and two is type. So that we have valence points, and later we have dependence. All right, so I think let's break it down into a list. So we have that. So instead of visual block, now we'll have to start renaming things. But before we do that, let's just go ahead and provide a function that will produce a visual representation of a fork. For fork block visual. So it takes a string, because that's the content of a fork, and it will also return a string. So for now, let's equate this to a visual block. And as we construct our structure, let's remove some of these. And we should just get a simpler diagram like this. This is already looking pretty neat. So instead of 21, let's do 11. That way we could fit more on the screen. Perfect. Now, how does one represent a fork? Let's resort to the white paper. Some of this we'll have to borrow from Visual Block Core. Is there 2 dashes? And now let's replace Visual Block with Fork Block Visual. It just rolls off the tongue. Okay. Now we just need to trace that line back to this point. Oh, this is going to be very hacky, but it's all right. So after we finish these dashes, we need 2 spaces and then pipe a new line. Let's see if this is correct. Nope. Oh, not these dashes. Okay. This is not the prettiest thing. Now, after this happens, we need another fill. This is nauseating. Let's say this is good enough. This is our fork. Or maybe something like this. Does look better. Okay. It's not looking too bad. But at the same time, we don't have to provide like a perfect visual representation. This is just to experiment with the new types. But at the same time, at the very least, I would like to be able to see valent points. Okay, so we have it wider. Let's make it also longer. think we'll need more depending on the visual block length. Let's make the fork even longer. So that there are two sort of lines between actions from every direction. Let's go one more. So here we can place a valence point. So a valence point will just mark as a V. Okay. Let's maybe make it a little bit more distinctive. Now let's stick to just V. It breaks the layout. And if we wanted to adjust, we would sort of erase the pattern that we've managed to formulate here. But it's fine. This is good enough. So what do we have here in the to-dos? Visual representation of words. Yes, we do have that. Data type representation of valence points and dependent. So we do have that. Now, let's start thinking of a data type that would be good enough to place inside a skewer block so that skewer blocks can contain other letters and words. But to that, I'll return in a second after a little break. I'm back, so time to look at the time and realize that we should probably be wrapping this up. So what I would like to do is to come up with a data type for the upgraded skewer blocks that should be capable of holding other words and dependents as words and letters as its dependents. let's not be that general here. Let's just go with fork block. So a fork block needs content. And it also needs left. That can be, and this is where the situation starts getting a little bit tricky. Or maybe not, because it needs a block there. And do we have, yep, we have a type diagram block. And right section of the fork. Comma, comma. So we'll have to change how we construct this. So 82. So we'll also have to change how we construct this. And just because I'm insecure with my brackets, let's just surround everything with brackets. Let's just do an action to the left and action to the right. $67. Yeah, and the complications start here. Because I would have to provide an argument to construct fork block, but show doesn't take any arguments. You know what, let me think about this. And in the meantime, let's just stick to what used to work. And we'll come back to this during the next session or sessions. But essentially, we're looking for something like this. I don't think this type will change much in the short-term future. Yes, so during upcoming sessions, I would like to provide a data type that would represent a fork, and two, provide a visual representation for the data type so that if a fork has, say, a left, that left gets rendered. Obviously, not recursively, just the first left on the list is rendered. We're not going to be going down the rabbit hole of if fork has a fork, then if that fork has a fork. No, it's just the first dependent. We'll get to that though. That's my goal. Yeah, so that would be a good idea for the next session. Right. Having said that, I hope you enjoyed this one. Thanks very much for joining me today and for your patience. And I hope you have a fantastic day, and I'll see you next time.